Hey everyone, welcome back. In this video we're going to be going over lambda expressions in a little more detail and looking at how they really work inside. So the first thing we're going to do is let's just declare an array list that stores a bunch of integers. My ints, and we'll do it like this, and let's just do that. We can myInts.addAll, and then we're going to use our arrays class and then do as list, and then let's see here, now we want a bunch of integers, an integer array that we're going to populate, and then let's put some integers in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, good. So now we have an array list that has these integers inside of it. So now what we're going to do is we're going to do myInts, and we're going to open up a stream. So we're going to open up a stream, and for now let's just print everything out, make sure everything is working correctly. So this is a consumer, so then what we're going to do is we have we have this item I, and let's just system.out.println I. We're just going to print it out, and we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Now, let me explain how or why, what a pipeline is. Yeah, so whenever we work with stream APIs, what we're doing is first we're specifying a source. We first call the stream method on a source. In this case, the source is our array list. Then what we do is we specify a bunch of, or we specify maybe no, intermediate operations. So these intermediate operations are things we're going to be doing to the stream. Just like we might be sorting this list, for example, or we might be filtering it so that we're only fetching items that are less than 5. Those are intermediate operations. Then we finish up with a terminal operation. In this case, this terminal operation is like this for each statement. And this closes the stream, you can think about it, and actually causes it to execute. If we didn't have this terminal operation, you would see, like, for example, suppose we did this. We open up the stream, right? And let's filter. So we're going to filter, and we're going to use a predicate, right? You take in some kind of input, and then, let's see here, we're going to use some braces because we want to do some custom stuff in here, right? And what a predicate does is it returns true if, if we want to, or I guess in this case, we have a filter method, and we're going to return true if the item I should be within the final set that we look at. Otherwise, we return false. So how about we do this? We return true, or so if I is less than 5, then we're going to return true. Otherwise, we're going to return false. Those of you that haven't seen this operator before, it's called the ternary operator. Ternary operator. And it pops up sometimes, so it's good to familiarize yourself with it. What it says is this is kind of like an if statement. First, you evaluate this expression on the left-hand side. If this expression is true, then you take this value and you return it. Otherwise, you take this value and you return it. For example, int x, and let's say if 1 is less than 2, then we'll let x equal 3, otherwise we'll let it x equals 4. In this case, x is always going to be 3, this first value, because 1 is always less than 2. So this is the first value we take. If we did something like this, see if we have this compiler error here, and it's because we're never gonna get this 4. If we did it like this, 1 greater than 2, it evaluates to false, and so we're going to get the false value from this ternary operator. We're not going to get this 3. It's equivalent to doing this. If 1 is less than 2, then x equals 3, else x equals 4. So that's all this ternary operator does. So now, let me comment that out, and here, I'm just going to delete this actually. So if we did this, and let's include a print. And let's just do this. we're just going to print out I every time we filter. So now let's run. And what do we see? This is interesting. We see 1, 2, 3, 4, 5, and then notice how the 1s get repeated twice, the 2s get repeated twice, 3s get repeated, but then after we hit 5, they stop repeating. So why is that happening? Well, let's make this a little more clear. So now you can see that we're inside the filter for a lot of them. So what's going on is that for each item inside of this list, we're going to go inside this for each loop, right? So it's going to be, we're going to start at I equals 1. So I equals 1. So I equals 1 is magically passed into this filter statement, and then we either return true or false for whether we should process I. If I is less than 5, then we're allowed to continue with this lambda expression inside of our for each loop. Otherwise, we just skip to the next item inside of our list. So 1 is less than 5, and so we're going to execute the stuff inside of this for each loop. Then we go on to the next item, and 2 is less than 5, 3 is less than 5, 4 is less than 5. But when we get to 5, notice something interesting happens. When I is less than 5, when I is equal to 5, what's happening is that we're passing 5 into this filter statement, and then we're returning false from it. When we return false, we don't do anything inside of this for each and lambda expression, and so we just do the stuff inside the filter, but we don't do anything inside of this terminal operation. So this is known as lazy processing, and it makes your programs a little faster because you don't have to do this for each stuff. You don't have to do the contents of this for each loop for every item inside of your list. So that's lazy processing. So now let's do something a little more tricky. So now what we're going to do is let's sort each item. So we're going to sort it. Right now it's sorted in ascending order, so let's just reverse it by sorting it in descending order. So we're going to use a comparator, and the way this works is we need 2 values. We're going to have 2 values, A and B, and let's see here. We need to, so how can we do this? Can we do integer.compareTo? Yeah, so we can just use this compare function provided by the integer class. It's a static method. It's going to be pretty convenient. So what we're going to do is, let's see, wait, hold on. Is this going to sort it in ascending or in descending? I believe if we just switch the order of these parameters like that, then it should still work. So let's just test this out really quickly. I'm going to remove this filter, and then I'm going to run this, and what are we going to get? Yeah, so it's going to print it out in descending order now instead of ascending order. So now let me wrap this lambda expression inside of some braces, and whenever we wrap it inside of braces, we need to actually specify the return keyword. So now let's do that, and let's print some stuff out inside of here. Sorting items. So now we run. And how many times are we sorting it? We're sorting it once, we're going inside the sort 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So what's happening is that each time inside of our loop, notice what we're doing is, so I is equal to, or sorry, we're not sorting it 10 times. This is, you can imagine this as sorting the entire collection at once. It's not like we're going for I equals 1 and then sorting the entire list and then going to I equals 2 and then sorting the entire list and then I equals 3 and then sorting the entire list. No, notice that we're sorting everything and then we're going into the for each, this for each terminal expression. What's going on is that it's using some kind of, some kind of algorithm to sort the items, and each time it needs to, each step of the algorithm in which it needs to compare 2 items, it's calling the sort items method. It's just going inside of here and printing the contents out. So don't think that we're sorting everything 10 times. We're sorting everything once, and then we're allowed to process everything, and then we're allowed to go inside of the for each lambda expression. So now, if we did this, what do you predict is going to happen if we have a filter expression and we have a sort expression? Now, if we run this, we notice that we're inside the filter. So what we're doing is we're filtering the items first, so we get 1, 2, 3, 4, 5. And then we're going to, because we're looking at items that are less than 5, we're just going to get 1, 2, 3, and 4, right? Now what we're going to do is once we filtered all of those items, then we're going to go into the sort method. Notice the order that's going on in here, right? First we're inside the filter and we filter all the items that we want. Then we sort the items. Once we sort the items, then we proceed into this for each loop and then we print out each item. So again, this is kind of an example of lazy processing, because what we're doing is we're providing a smaller data set to our sort method than we otherwise would. Normally we would provide 10 items and then we would sort and then we would print it out. So for example, if we did this, if we rearrange the order of these sorts, our program would be a little less efficient because we're sorting all of the items and then we're filtering. So let me run. And so notice we're sorting the items and then we're going inside the filter. Like notice how many more sort calls are being made. The last time there were maybe 3 sort calls made. Now we have a lot more because we have to sort 10 items instead of 3 items or 4 items. And so you want to do this whenever you're sorting. You want to filter first, you want to map all your values, and then you want to sort. Because when you sort, you're probably looking at a reduced data set. Okay, so that was an introduction to pipelines, or a more thorough explanation of how pipelines work and how the Stream API works. I'll see you guys in the next video.